Next part of our lecture, we are going. This, of course, this is the chapter 2, which is Introduction to Engineering Geology. We studied the crust. Now we are going to go a little bit deeper. We are going. The crust was there. This top part is the crust. Now we go to the mantle. The mantle is something between the core and between the crust. What is the mantle? It is still solid, but not as hot as the core. We said that the core is very, very hot. It can be the same degree of the sun. It's very, very hot. Nobody can reach this location. It is the largest layer. By the way, does anybody think why it is the largest layer? Why it should be the largest layer? عشان الكولينج سيستم. هو ده الكولر بتاع الأرث. فأنا عندي تحت I have a very, very hot core, and in the top, as I said, we may have degrees of 40 degrees, 50 degrees in some places, and I may have minus 40 and minus 50 in other places. So it is very, very cold. So how can I change from very, very hot core to this very cold? I need to have a radiator here, a cooling system here. This cooling system at least should be thick, so that there would be a gradual change of temperature. If we will come to discuss the temperature. What is the thickness of this layer? It is about 2,900 kilometers. Of course, as I said, it's not a fixed number. You may find it in another reference different, but you will not find it 1,000. Instead of 2,900, maybe 3,000. It may be 2,500. It's okay. They are all within range. This mantle is divided into two parts. The upper mantle, it's called asthenosphere. So it is another terminology that you have to know. It's not only it is an upper mantle, they can stick to upper mantle and that's all, but they needed to add another description. So it is the asthenosphere. The lower mantle is called the mesosphere. So this mantle is divided into two parts. Let's discuss the upper mantle, which is the asthenosphere. Let's check this again. This is both of these are the core. We did not study the core, but we are going to study now the mantle. We studied the crust, and we said all the groups of the crust. Then we are going now to study the mantle. The mantle is divided into upper and lower mantle. The upper mantle, it is directly below the crust, in which there is relatively low resistance to plastic flow, and convection is thought to occur. So in this upper mantle, the convection currents happen. This is the place where we have this movement for the cooling system of the Earth. Mostly made up of metallic silicates and sulfides. The thickness is about 200 kilometers. 200 out of 200, 2,900 kilometers. So the upper mantle is not very thick compared to the remaining. The lower mantle represents approximately 50. This is the biggest part of the Earth, about 56% of the Earth's total volume, and is the region of 660 to 2,900 kilometers below Earth's surface, between the asthenosphere, which is the upper mantle, and the outer core. So the lower mantle is between the upper mantle on the top, which is the asthenosphere, and the outer core. You have to draw this. You have to draw the core, which is divided into upper and lower, then the mantle, which is divided into upper and lower, and then the crust, which is divided into not upper and lower, but it is divided horizontally. There are parts biosphere, there are parts, we said hydrosphere, and so on. So this you have to memorize. It is very easy if it is drawn with a sketch plus few definitions. It will be very easy, inshallah. Then we go to the last term, which is the core. The core is the inside of the earth. We said that the core of the earth is divided into outer core and inner core. What is important about the outer core? The outer core is liquid. By the way, if you remember, maybe a year ago or something, somebody said that, and it was very, people used to share this information. They said that the earth started to rotate in the opposite direction. Some people said that, and they started to link it to the doomsday and so on, that we are about, that the earth is going to move in the other direction. What really happened, this is the importance of studying. When you study something, you understand the wrong data that people share with each other. What started to rotate in the opposite direction is the inner core, this solid part, and it moves in the opposite direction sometimes, and it is normal. It is not something that geologists were surprised to hear. No, it happens because the inner core is loose. It is as if you have a solid ball inside of a liquid, and the full put all of this in a jar. If this jar is moving, this ball inside, it may move in any direction. It has nothing to do with the movement of the earth itself. So this is something that I would like to link to what you may have heard before. So we have the outer and the inner core. Let's discuss both. What is the outer core and what is the inner core? I will start with the inner core. The inner core is very hot and thought to be as hot as the surface of the sun. Solid and composed of nickel and iron. Radius of about 1,200 kilometers, temperature of about 5,000 to 7,000 degrees. 7,000 is the degree of the sun. So the temperature of the sun. So this is the inner core. So it is, there are many, here the inner core is very important because you know that the inner core is solid, it's very, very hot. The radius is more or less about 1,200 kilometers. It may be more, it may be less, but it is an approximate number. What about the outer core? By the way, when I finish this, we are going to go to some application, and you will know what is the importance of studying this outer and inner core. Usually, I try my best to give you the importance of the data that you take that is a little bit silly or a little bit tedious to study, but it is important that you know it. What about the outer core? The outer core is hot, but less than the inner core. It is less than the inner core. It may be 4,000 or 5,000 degrees. Here it is 5,000 to 7,000 degrees. But we are speaking about thousands of degrees. Still, the core, whether outer or inner, it is very hot. It is composed of nickel and iron. Here it is composed of nickel and iron. So the composition is the same, but the only difference is in the temperature and in the state. Here it is, the inner core is solid, the other is molten. It is liquid. So this is what is important, and the difference between the inner and the outer core. Let's go to the importance. We said that usually in earthquakes and in many things, we try to anticipate that there will be an earthquake in some place. How we are going to know? So far, we don't have enough studies to tell us that how the earthquake will happen or when it will happen. But usually, when we see a minor or a surface earthquake in one location, we may expect that this earthquake would reach another location. So if I manage to monitor the movement of the crust in one location, then I may have maybe few minutes to give people an alarm, take care that there will be an earthquake in few minutes, so that they would leave the buildings. This is the maximum we can do so far. How can we do this? We go into something related to waves. We study, now we are going to combine sciences together. Now, we studied geology, now we are going to leave geology and we are going to study waves. If I have a source of wave, there are lots of waves coming from this wave. Scientists want to study only two important categories, something called the S wave and the P wave. P wave, it is more or less something like a pressure wave. S wave, it is more or less something like a shear wave. It shears the ground. It's the shear inside. You know what is shear? Of course, you took it in structure. So the waves that are affecting by the shearing forces is called S wave. The waves that are affected by the pressure is called the pressure wave. If I start with a wave at the surface of the earth, and then this wave goes into the mantle, and then in the mantle, we said that the mantle is solid. So in this solid, the S wave, the velocity of the S wave is small, but the velocity of the P wave is high. Here is the velocity, and here is the depth. So the velocity of the P wave is very high compared to the velocity of the S wave. It will continue to reach the bottom of the mantle. Once it reaches the bottom of the mantle, then we will find a very strange features happening. What is this feature? We entered from solid to liquid. So the wave, the S wave, will stop because it depends on shear. Can anybody shear water? If you have, can you stand on top of water? No. You will have shear failure. You are going to penetrate the water and go inside. So the shear wave will stop, but the pressure wave, if you have a small piece of rock and you throw it in the water, you will find circles. These circles are pressure wave because the piece of rock that you have immersed in the water pressurized the surface, and this wave started to move. So the pressure wave will continue, but it will continue with a smaller velocity till it reaches the inner core and so on. This is just a graph to show you the temperature. This is the temperature at the inner core, and this is the temperature at the crust. We said it when we were discussing the layers. But what I need now to concentrate on is this. The S wave, once it reaches the outer core, it stops, and the shear wave and the pressure waves continues, but with a lower velocity. Why this is important? Imagine that this is the Earth, and you have an earthquake here. In this earthquake, you will find that the S wave, what is the S wave? This is the S wave. The S wave is the wave that we said that it cannot penetrate the the outer core. So the S wave will come here with a small velocity, it's not very high velocity, and once it reaches this core, it will stop. It will not continue. But the waves that travel here may continue because it is outside the core. What about the P wave? The P wave is, it can penetrate here. The P wave is in the dark color. This is the S wave. The S wave is here. They just took it from here, put it here. So this is the S wave. This is what managed to come to these points. So, but the P wave managed to continue and to go to the other direction. So if I have monitoring stations all over the earth, and this is happening, if you, in Egypt you have monitoring station, in UK monitoring stations, everywhere around the earth you have monitoring stations. All of these stations are linked together, they connect, they share data together. So once if I have a monitoring station here, I will monitor the P wave and S wave. Here I will monitor only the S wave, and here I will monitor the P wave, and so on. So each station will share the data, and based on all of these data, they can reach that there is an earthquake at this location. By analyzing the data, they take this data, put it in a cycle of analysis, and then they can, of course, this is computerized because they don't have time. We are speaking about few minutes. If I don't analyze this data in few minutes, I can expect that I have an earthquake at this location, and I can give an alarm for people around this location. So here, as I said, that this is an application from the geology that helped me in preventing, or at least knowing or expecting an earthquake to happen. Last thing to end this lecture is something called inclination and declination. This is not important for us as engineers, but it is very important for sailors. If you remember, or maybe you did not hear about it, but there is something called geographic north and true north. I usually say north. If I'm in Egypt, then my north would be maybe in Cyprus, Turkey, Italy, something. This is the vertical direction to the top. This is the north. But actually, if I have a compass in my hand and I look at the deflection of the compass, I will not find that it is actually going to the north. It is a little bit shifted. This shift is called an inclination angle. It is inclined. Why it is inclined? Because there is something called the magnetic north. This earth has a magnetic field. It is a little bit deviated than the true north of the earth. Why is this important? Because if I am a sailor and I have a compass in my hand and I go with the compass, I will not reach my destination. I have to make a correction for this north so that I know that if somebody tell me that I have an 11.5 degree inclination angle, then I will head my ship to this geographic north, and then I will shift it 11.5 degrees, then I will go to the geographic north exactly. So this is important for marine world. So there is something called the inclination angle. This is one thing. There is another thing called the declination angle. What is the declination angle? The declination angle is that if you put your needle of the compass it will not be horizontally. It will be a little bit shifted down, declined a little bit. Why? Because of the Earth's magnetic field also. So there is inclination and declination. These two terms, by the way, we are just studying the name of the term. We are not going to study anything, but we know the term and we know the impact of this term on our study as engineers, not specifically civil engineers, any engineers. So there is declination and inclination. Inclination is horizontally, declination is vertically, and this it tells you that do not depend on the compass to give you the true north. It may give you a different north depending on your location of the earth. It's not the same if you are in Egypt, not like in UK, not like in China. Every place has a different declination angle, and the inclination also it may have a different value. Well, this ends our lecture for today. Sorry for the lots of terms that you had to study, but this is, as I said, this is ABC Geology. We have to understand it. If you leave this lecture and do not study it and put it in writing, then in the next lecture you will be more confused, because you will have new terms, and these new terms are going to add to the previous terms. If you don't memorize them, or at least know a little bit about how to differentiate between them, then you will have problems. So please don't have these problems. Thank you, and see you next time.